Imagine you find a mouth, just a mouth. No body, no eyes, just teeth and jaw pieces. Scientists think this must be from a tiny worm. Then they find more pieces and realize this mouth is huge. It belonged to a creature the size of a grown man. Here's the crazy part. It was built almost entirely around that mouth. A predator 5 feet long that was basically just a giant set of teeth. Our story starts with a mystery. In the early 1990s, scientists digging in China found something weird. Ring-shaped objects made of hard material, arranged in perfect circles, just a few centimeters wide. What were these? Scientists thought they came from priapulid worms, tiny creatures that use similar rings to grab food. But something didn't add up. These ancient rings were way too thick, way too strong, built like armor. A few brave scientists thought differently. What if these rings came from something big? Maybe over 3 feet long? Nobody had heard of a worm that big. But maybe this was something different. Then a new idea became popular. The rings looked like the mouth of anomalocaris, one of the scariest hunters in ancient oceans. Maybe these were from an even bigger version? A supergiant, 6.5 feet long? For several years, most scientists believed this. But then they looked more carefully. The rings didn't match perfectly. The plates were bigger, arranged differently. Not quite right for a radiodont mouth. The mystery got deeper. This creature was something between a worm and a predator. Something that didn't fit into any known category. The answer came from a new fossil site, the Xiaoshiba Lagerstätte in Yunnan. Scientists found more rings here. But this time, something amazing happened. The pieces were found together, connected. Finally, scientists could see how all the pieces fit into one mouth structure. When they put it all together, they realized something shocking. This wasn't a worm. And it wasn't an anomalocaris. It was something completely different. A panarthropod, an ancestor to all modern arthropods. The scientists measured the pieces. Some plates were several centimeters wide. When they calculated the whole creature's size, 1.5 meters. Nearly 5 feet long. The biggest animal living freely in the entire Cambrian Ocean. Suddenly everything made sense. The thick plates, the strong structure, the weird symmetry. These were pieces of one creature called Omnidens, meaning all tooth. This discovery changed everything. It proved the ancient oceans were way more complicated than anyone thought. The mouth of Omnidens was engineering perfection. Picture 2 crescents facing each other, left and right sides like mirror images. Each crescent had 6 main plates, wide at the bottom, pointed at the top like teeth. Between the main plates were smaller inner plates, all arranged in neat rows. The inner rows had 3 to 5 spines each. Spines got smaller and closer together, going deeper into the throat, like a tunnel of hooks. Once something went in, it wasn't coming back out. This mouth was massive. While other creatures had tiny mouths just millimeters wide, Omnidens could open to about 8 inches wide, big enough to swallow small arthropods whole. Everything was extra thick, extra strong. One thing was clear. I hunt big things. Just beyond the mouth opening were 2 special structures, talon-like claws. Each had 8 to 10 flat spines arranged in a line like shark teeth. These claws were both stiff and flexible, strong enough to grab struggling prey, flexible enough to adjust to different sizes. The claws pointed toward the mouth. They were part of one hunting system. The claws grabbed, pulled prey toward the mouth. The mouth opened. The spines grabbed hold. The mouth closed. Everything worked together. This was coordinated hunting technology. For years, scientists thought the mouth was round, like anomalocaris. But in 2024, researchers found something important. The mouth had 2 distinct sides, left and right, mirror images. This is bilateral symmetry. Why does this matter? Because it changes everything about how the creature hunted. A round mouth works the same no matter which way you turn it. But a two-sided mouth has a front and back, left and right. The creature could control where it grabbed things. It could aim. It could position itself differently. Think of it like this. Anomalocaris could suck things in, but Omnidens could grab them at an angle. More control, more deadly. This two-sided design became the standard for all future arthropods. Spiders, insects, crabs, everything. Omnidens was using this design 520 million years ago. It was ahead of its time. Scientists think bilateral symmetry gave creatures a huge advantage. Better movement in 3 dimensions, faster direction changes, better hunting. That's probably why bilateral design took over the animal world. It was just better. For Omnidens, this two-sided mouth wasn't just a design choice. It was a competitive advantage. For years, all mouth fossils belonged to one species, Omnidens amplus. Then scientists found new fossils at Xiaoshiba. Different fossils, different design. Plates arranged differently, spines positioned differently. A second species, Omnidens kyongki. This was huge. It meant Omnidens wasn't just one creature. It was a family of creatures, different versions. All giant-mouthed predators, but specialized differently. O. amplus had a round mouth. Its strategy was probably to open wide and swallow prey whole. O. kyongki had an oval mouth with sharp cutting ridges. It was better for cutting and shredding prey. The talon-like claws were even more blade-like, better for clamping and tearing. Evolution was experimenting. Some versions were better at swallowing. Others were better at cutting meat. They probably lived in different areas or hunted different animals. We know O. kyongki was successful because we find so many fossils at Xiaoshiba, hundreds of them. This means the population was thriving. The design was working. Now let's compare Omnidens to its rival, Anomalocaris. Anomalocaris was built for speed, light body, fast appendages, perfect for hunting small, soft creatures. But those delicate spines would break against hard shells. Omnidens was completely different. It was built for power, thick plates, reinforced structures, could close its jaws and hold on, could bite and not let go, could handle prey with hard shells, could handle prey that fought back. Imagine 2 hunters. One is a cheetah, fast, sleek, perfect for small prey. The other is a bear, powerful, strong, can crush anything. Anomalocaris is the cheetah. Omnidens is the bear. At 5 feet long, Omnidens was one of the biggest free-living animals of its time. Built to hunt big things. It probably lived in deeper waters with enough oxygen for an active predator. Probably ate other arthropods, trilobites, or other large creatures. Omnidens may have been the true apex predator of the mid-Cambrian ocean floor. Not the most famous, not the fastest, but the most powerful, the one at the top of the food chain. Here's the big mystery. What even was Omnidens? Was it a worm? Number. It didn't have a soft, flexible body. Was it an arthropod? Not quite yet. It didn't have jointed legs. It was something in between. And that's exactly what makes it so important. Other creatures like Pamdelurian were soft-bodied. Simple limbs, no hard skeleton, just flexible, spiny arms. Omnidens was different. Its front end had hard, stiff structures, sclerotized plates, reinforced spines, a skeleton starting to form, but the rest of its body was probably still soft and flexible. This shows evolution didn't happen all at once.